Have you ever wondered how electricity powers our homes and devices? It all starts with electric circuits. An electric circuit is like a pathway that electricity follows. It's a closed loop that allows electric current to flow. Think of it like a racetrack for electrons. These circuits are everywhere. From the tiny circuits in your phone to the complex wiring in your house, they make our modern lives possible. By understanding the basics of electric circuits, you can gain a deeper appreciation for the technology that surrounds us. Let's imagine building a simple circuit. This is a fundamental exercise in understanding how electricity works. We need a few key components to get started. Each component plays a crucial role in the functioning of the circuit. First, we need a power source, like a battery. The battery provides the necessary energy to drive the circuit. This energy pushes the electrons along the circuit, creating an electric current. Think of it as the engine that drives the electric current, powering everything in its path. Next, we need conductors, like wires, to act as the pathway for the electricity. These conductors are essential for connecting all the components. Conductors are materials that allow electricity to flow through them easily. They are the highways for our electric current. Copper is a great conductor, that's why we use it for wires. Its efficiency makes it ideal for electrical circuits. Now, we need a load, such as a light bulb. The load is the component that consumes the electrical energy. The load is what we want to power using our circuit. It could be anything from a light bulb to a motor. It's the reason we built the circuit in the first place. Without a load, the circuit would have no purpose. The load resists the flow of electricity and converts it into another form of energy, such as light or heat. This conversion is what makes the load useful. Finally, we need a switch to control the flow of electricity. The switch allows us to turn the circuit on and off. The switch acts like a gate that can open and close the circuit. It gives us control over the flow of electricity. When the switch is closed, the circuit is complete and the electricity flows. This flow of electricity powers the load, completing our simple circuit. Electric circuits can be arranged in different ways, with series and parallel circuits being the two most common types. Each type has its own unique characteristics and applications. In a series circuit, the components are connected one after another, forming a single pathway for the electric current. This means that the current flows through each component sequentially. Think of Christmas lights wired in series. If one bulb goes out, the entire string goes dark. This is a common example that many people can relate to. This is because the circuit is broken and the electricity cannot flow. The interruption in the pathway stops the current from reaching the other components. In a parallel circuit, on the other hand, the components are connected on separate branches. Each branch provides an independent pathway for the electric current. This means that the electric current has multiple pathways to follow. Each component receives the full voltage of the power source. If one component in a parallel circuit fails, the other components can still function because the electricity can bypass the faulty component. This makes parallel circuits more reliable in many applications. Think of the electrical outlets in your house. They are wired in parallel. This setup ensures that each outlet operates independently. This allows you to use multiple appliances simultaneously without affecting each other. Each device gets the power it needs without interference from others. Section 4. Ohm's Law and its significance. Ohm's law is a fundamental principle in electricity that describes the relationship between voltage, current, and resistance. It is named after the German physicist Georg Simon Ohm, who first formulated it in 1827. It states that the current flowing through a conductor is directly proportional to the voltage across it, and inversely proportional to the resistance. This relationship is often expressed with the formula VIV equals sine IR, where V is voltage, I is current, and R is resistance. In simpler terms, this means that increasing the voltage increases the current, while increasing the resistance decreases the current. This principle is essential for understanding how electrical circuits function. Imagine using a garden hose. The water pressure is like voltage, the water flow is like current, and the hose diameter is like resistance. Adjusting the nozzle changes the resistance, affecting the flow of water. Ohm's law is crucial in circuit design and analysis. It helps engineers understand how different components will interact within a circuit. It allows engineers to calculate the appropriate components and parameters to ensure the circuit operates safely and efficiently. Without Ohm's law, designing reliable and functional electronic devices would be much more challenging. Section 5. The importance of understanding electric circuits. In today's technology-driven world, understanding electric circuits is more important than ever. From the smartphones in our pockets to the computers that power our homes and offices, circuits are the backbone of modern electronics. Knowing how circuits work enables us to use these technologies effectively, troubleshoot problems, and even invent new devices. A basic understanding of electric circuits empowers us to navigate our increasingly digital world with confidence. By grasping the fundamental concepts of electric circuits, we open up a world of possibilities and gain a deeper appreciation for the invisible forces that shape our lives.